Hello students, so this is lecture number 3 of the chapter gravitation, and in this video we are going to see Newton's law of gravitation in vector form and Kepler's third law, right? So in the previous video, up till now we have seen Kepler's first law, Kepler's second law, proof of Kepler's second law and Newton's law of gravitation, but not in the form of vector, right? Okay. So in the previous video we have seen that the force between two masses is g m1 m2 by r square, where m1 and m2 are the masses, g is universal gravitation constant whose value is 6.67 into 10 raised to minus 11. Now as force is a vector quantity, we need to specify the direction also, right? So we'll now understand what is Newton's law of gravitation in vector form. X, Y. Suppose there are two objects, two particles, mass m1, so it is at a position r1, mass m2 having a position r2. Now we want to find force on anyone. Let us say force on 1 because of 2, right? We will also find force on 2 because of 1. Okay, so force on 1 because of 2. So force on 1 because of 2, 2 will attract 1 towards itself. So the direction of force will be this way, right? So F12 is equals to G M1 M2 upon. Now the distance between these two masses is, let us say this as the distance as x, right? Distance as x. So it will be x square into unit vector. This unit vector is to show the direction of the force, because force is a vector quantity. So since force is in this direction, unit vector is along x. Okay, now x can be written as, see, this is your r1, right? X is in this direction, this is your r2. So from the law of vector, from the laws of addition of two vectors, r2 is r1 plus x, because in vector we have seen that head of first vector, from there tail of second vector, and this will be the resultant vector, right? So from this we can say that r1 plus x is equals to r2, a plus b equals to c, r1 plus x equals to r2. Therefore x is equals to r2 minus r1. Clear? Kindly do not by heart this, that if here it is 1 2 then write it as r2 minus r1. No. Perform a vector addition and then only you write this, because when you will be studying about electrostatics, this will be r1 minus r2, right? So don't by heart this, perform vector addition and then find what is x. So in a present case x is r2 minus r1, so substitute this, we'll have F12 is equals to G m1 m2 upon r2 minus r1 the whole square. Unit vector, what is unit vector? Vector upon its own magnitude. So it can be written as x upon its own magnitude. So finally F12 is equals to G m1 m2 upon r2 minus r1 the whole square into r2 minus r1, because x is r2 minus upon magnitude of r2 minus r1. Right? So finally F12 is G m1 m2 upon r2 minus r1 the whole cube, 2 and 1, so 3 into r2 minus r1. Clear? So this is the force on 1 because of 2. Now let us calculate force on 2 because of 1. Clear? Okay. This is force on 1 because of 2. Now if you have been told to calculate force on 2 because of 1, so 1 will be attracting 2 towards itself. So the direction of force will be towards M1 or away from M2. So now X will be in this direction, right? So again F21 will be G M1 M2 upon X square into unit vector X caret. Now since X is in this direction, the vector addition can be performed as this is R2, head of first vector, tail of second vector, this is R1, right? So in this case R1 is the resultant of R2 and X. R1 is result of R2 and X. So here we can write it as R2 plus X equals to R1. So X is equals to R1 minus R2. Is it clear? This point is very important actually, that what to substitute in place of X, right? Many a times students will make a mistake that instead of X, if they have taken this as memory, that means if they have biarted these things and instead of R1 minus R2 they might substitute R2 minus R1, so then answer will differ. So better perform a vector addition. So in this case X equals to R1 minus R2. So substituting the value, F21 is equals to G M1 M2 upon R1 minus R2 the whole square into unit vector, so that is R1 minus R2 upon magnitude of R1 minus R2, right? So here it is 2 and here it is the power is 1, so I can write it as Q. See, already this is written in mode, it is written in magnitude. So whether you will write R1 minus R2 or R2 minus R1, it won't make any difference here, but here it can make the difference, right? So I'll write it this as F21 equals to, I am placing a minus sign, Gm1 M2 upon R2 minus R1 the whole cube. It won't make any difference because we are placing magnitude here, but here I am putting a minus sign, so here I can write it as R2 minus R1, right? So it is minus of R2 plus R1, so R1 minus R2. But now what is Gm1 M2 upon R2 minus R1 the whole cube into R2 minus R1? F12. So finally we can say that yes, F21 is equals to minus F12. So Newton's law of gravitation will obey Newton's third law of motion. Both the forces are equal in magnitude and opposite in direction. Another thing, gravitational force is a central force. That means if two bodies are at same line M1 and M2, the force will be acting in the line joining, on the line joining between two bodies, right? If M1 and M2 are here, the force will not act here, the force will not act here, right? M2 will be attracted by M1 towards itself. Similarly, M1 will be attracted by M2 towards itself, towards M2. Clear? So it is the central force, that means the force will be acting in a line joining the charges, line joining the masses, sorry. Now, so this is what is gravitation law in vector form. Now we will understand what is superposition principle. What is superposition principle? Superposition principle, what if there are more than two masses and we have been said to calculate the gravitational force on a single mass? That means suppose now the arrangement of the masses is something like this: a mass M1, a mass M, R1, R, say mass M2, R2, M3, R3 and so on, right? So there are multiple masses M1, M2, M3, they are having the position vectors R1, R2, R3, a mass M having a position vector R. Now suppose you have been said to calculate force on this mass M. Let us say this has 4, this 1, 2 and 3. So you need to calculate the force acting on the fourth body, right? So gravitational law is between two masses. In the present case we are having 4 masses. Then according to principle of superposition, it states that the resultant force on the body will be equals to the vector sum of the gravitational force between two bodies. It means we want to find the resultant force on fourth body. So we'll find it like the force on fourth body because of 1 plus because of 2 plus because of 3, and we'll have a vector addition of all these forces. So according to principle of superposition, the net force or the resultant force on any body will be equals to the vector sum of individual forces. That means the force on M because of M1, because of M2, because of M3, because of M4, M5, M6, M7, dot dot dot. The vector addition of all these forces will be the resultant force acting on a particular mass. This is what superposition principle says. That means, like suppose M1 will be attracting M towards this direction, M2 will be attracting in this direction, M3 will be attracting in this direction. So one force is force on 4 because of 1, right? Force on 4 because of 2, and force on 4 because of 2, and this will be force on 4 because of 3. The vector addition of all these forces will be equals to the resultant force on a body placed at 4. So this is how we will solve this. Force on the body fourth will be equals to, because of 1, force on fourth body because of first body, force on fourth body because of second, because of third. If there were more than 4 bodies, then plus because of 5, because of 6, so on. Now here we will just write the formula for gravitation law. G m1 m upon this distance. How to calculate this distance? So this is your r1, this is x, this is r. So r1 plus x is r, so x will be r minus r1. So here you can write it as r minus r1, the whole cube into r minus r1. Similarly, plus force on fourth because of 2, so that will be G m2 m upon r minus r2, the whole cube into r minus r2 plus so on. Clear? So net force will be sigma. Sigma means addition. I equals to 1 to n. If there are n number of masses, then G m will be taken common. M of I upon r minus ri, the whole cube into r minus ri. Clear? Yes, but force on nth body cannot be, means if you are being said to calculate force on fourth body, then this is never possible. This is not possible, that force on fourth body because of fourth body. This is not possible. A body will not exert force on itself. Clear? So this is how the total force can be calculated by using the principle of superposition, in which you just have to add the forces, all the forces acting on a single body. The addition should be done with the help of vectors. Direct addition is not done. Clear? See, we will see one question based on Newton's law of gravitation in vector form, and where we will be using the principle of superposition also, right? But before that, we will just see what is Kepler's third law, right? Kepler's third law. Okay, so Kepler's third law, previously we have seen both the laws of Kepler. This is the third one. According to third law of Kepler, the time period of a planet revolving around the sun in a circular orbit, the square of the time period is proportional to cube of the distance between them, or you can say that the cube of semi-major axis. Once again, according to third law of Kepler, it states that the time taken by the planet to complete one revolution, that is known as time period, right? Time period means time taken by the planet to complete one revolution, right? Let us say that planet revolves in a circular orbit around the sun. This is the sun. The planet is revolving around the sun in a circular orbit. According to Kepler's third law, the square of the time period of a planet is proportional to cube of the distance between them. right? So this is what we have to prove mathematically, that the square of the time period of a planet is proportional to the distance between the sun and the planet, or proportional to cube of the distance between the sun and the planet, that is t square. T stands for time period. Square of the time period is proportional to cube of the distance between them, or cube of semi-major axis, right? Here we have just considered, we have just assumed that the planet is revolving in a circular orbit, right? In Kepler's first law, we have taken elliptical orbit. Okay. So for a planet to revolve around the sun in a circular orbit, it requires centripetal force. This is what we have learned, right? That whenever any object wants to perform, or whenever any object wants to move in a circular manner, they need centripetal force. In present case, the centripetal force mv square by r, this is the centripetal force required for the planet to revolve around the sun. This centripetal force will be provided by the gravitation force. Let ms be the mass of the sun. So the gravitational force of sun on planet will be in this direction. So this force will provide necessary centripetal force for the planet to revolve around the sun. So mv square by r equals to g m ms upon r square. Once again, the required centripetal force for the planet to revolve around the sun in a circular orbit will be provided by the gravitational force between them. So mv square by r equals to g ms m upon r square. M gets cancelled, 1 r gets cancelled. So v square equals to g ms upon r, right? Okay. V represents speed of the planet. For one complete rotation, we can write speed equals to distance by time. What will be the distance? 2 pi r. For one complete rotation, distance will be 2 pi r. So speed is distance by time, right? Substitute the value v square. So it will be 4 pi square r square by t square equals to g m of s upon r. So t square into g ms equals to 4 pi square r cube. T square equals to 4 pi square upon g ms into r cube. This term is constant. This is universal gravitation constant. This is mass of sun. So this whole term is constant. So t square is proportional to r cube, right? So this is what Kepler's third law is. The square of the time period taken by a planet to revolve around the sun is proportional to cube of the distance between them. Clear? This is what we have proved. Now, up till now we have studied Kepler's 3 laws and Newton's law of gravitation, both formula wise and in vector form. Now we will solve the sums, right, based on Kepler's law as well as superposition principle. Clear? But the sums will be taken in the next video.